Alright guys, we are talking about elements and compounds and mixtures today. So, let's do it. Classification of matter into groups. Okay, when we look at matter, which is if you can touch it, see it, taste it, feel it, smell it, it's matter. It's made up of stuff. So, we're going to look at what it's made up of, and we're going to classify them. The big two categories are either it's a pure substance or it's a mixture. So everything is matter, and it's going to be divided up into mixtures and pure substances. We're going to start with pure substances. Alright, so pure substances have unchanging compositions. Okay, that means no matter where you look at it, it's going to be the same throughout. Alright, so they have unchanging compositions. There are two types of pure substances, and those two types of pure substances are elements. Oops, I don't know what I just did there. Elements and compounds. Elements and compounds are our two types of pure substances, and let's look at them and see what they are. So, let's start with elements. You can't break an element down any further chemically or physically. Now, when we get further on to chemistry, when we get to nuclear, we'll talk about that. There's some cool stuff you can do, but talking about just in an everyday life and normal stuff, you can't break it down an element anymore. Basically, what you have is if you have an element, okay, usually it's a large group of it. So, this right here, aluminum, okay? Now, this is not one atom of aluminum, okay? If this was one atom of aluminum, it'd be really big atoms. No, this is billions and billions and billions of atoms of aluminum. So, if I try to break this, let's just say I broke it in half. If I try to break down this element anymore, guess what? If I try to break down the element down, I just get atoms. I just get atoms. Oops, I don't know what I'm doing here. Let's try it one more time. I just get atoms. Alright, that make up the element. So as I keep breaking this down and breaking this down and breaking this down, I still have aluminum. Okay? So all atoms making up a neutral element are the same. So if I have a chunk of gold in my hand, which I wish I had, but if I had a chunk of gold, they'd all be gold. If I had a thing of silver, it'd be silver. Now, there are ways to combine them, and we'll talk about that in a few minutes. But if you're talking about a pure substance, just the element, all the atoms making it up are just that one element. Alright, how do we know it's an element? Well, we look at the periodic table. You guys are going to be getting periodic tables if you have not already gotten them. And if it's on the periodic table, it's an element. There's 118 or 19 now elements that they've found / created. But they're on the periodic table. And on the periodic table, you'll have different areas of the periodic table. You have going up, and we'll look at this periodic table here, going up and down here. We call those families or groups, and going across this way, we call them periods. If you don't see a substance on the periodic table, it ain't an element. Okay? So, you can look as hard as you want for, let's say, salt on the periodic table, you're not going to find it. You can look as hard as you want for plastic, it's not on the periodic table. Alright, so some examples, we have gold, Au is gold, we have carbon, which is C, sulfur, calcium, we got oxygen, and that 100, about, it's an older thing I can tell, that about 114 there is actually a little behind the times. We have more elements now. Alright, compounds. So, if you put two or more elements together, you'll make a compound if you put them together chemically. Alright, so, can be broken down by chemical means. Alright, can only be broken down by chemical means. If you try to filter it or evaporate it or anything like that, which we will be talking about soon, you can't separate it. Okay, so let's say water, for instance. Okay, H2O, hydrogen, oxygen. Okay, it's a compound. It's got two different elements in it. If you wanted to separate the hydrogen from the oxygen, there's a couple things you can run electricity through it, and that'll actually separate the hydrogen and oxygen. So that's a chemical mean. Okay, there are certain elements you can put into it that would actually cause a chemical reaction to occur, separating the two. Alright? But I can't do anything physically to do it. I can't throw it through a filter and all of a sudden the hydrogens and oxygens break off. Nope. So that's what we're talking about there. Okay. If you're deciding whether something is a compound, just look at the periodic table. If you see two or more elements that make it up from the periodic table, you know it's a compound. Some examples. Here we go. Sucrose or sugar, C12H22O11. We got something here. Sulfuric acid. We got carbon dioxide. We got H2O here, water. Here's a hint. Okay. If you see two capital letters, it's a compound. Capital C, capital H, capital O. Capital H, capital S, capital O there. Alright, you see it? Now, you got to be careful. There are some elements, like sodium is Na, but look at this carefully. Capital N, lowercase a. Nope, that's just an element. However, if I look at Na, capital C, lowercase l, that's sodium, and that's chlorine. Look here, I got a capital N and a capital C. Sodium chloride. Uh-oh, compounds. Got it? Chemical changes involve elements and compounds. Okay, we're going to talk a lot about chemical reactions and chemical changes in here before, so don't get overwhelmed by this. You'll have a PowerPoint coming up soon that will go more detail. Just know that there's a term in here we call reactants. I want to write this one down. If I'm talking about a chemical reaction, which we'll talk about a lot about, reactants are what you start with, what you put together. And what you create are called products. So here are kind of two key terms here. Reactants, what you start with, products, what you end with. Okay? In a chemical change, matter and mass is not created or destroyed. Okay? You can't create or destroy mass. It's always there. So basically, however many reactants you start off, so if you start off with 30 grams of reactants, you must end with 30 grams of products. Alright? So here's an example here. If we have 2.5 grams of hydrogen, so I'm going to put this over here. I'm going to write it with it. So 2.5 grams of hydrogen. And you get 19.8 grams of oxygen. Now, there are starting stuff. These are our starting bits. If you remember, this is called reactants. And they're going to make our product water. So water is our product. So if this is how much we start with, how much water are we going to make? Right? This is going to be very simple. Okay, I promise. Right? You have your two reactants. All you got to do is add up their masses, and guess what? They have to equal whatever the product is. Conservation of mass. Mass can't be created nor destroyed. So if I add these up, let's see, I would get, carry the 1 there, 2, and 2. I'd get 22.3 grams of water. Start with, what you end with, have to be the same. Okay, well, we had pure substances. Those are elements and compounds. Let's look at the other thing, mixtures. Mixtures are two or more pure substances put together just by physical means. Okay, just by physical means. So we got a lady up here mixing some stuff. We got milk in the cereal. Okay, there are two types of mixtures, and those types of mixtures are, get to my pen here, those two types of mixtures are, let me make sure I get the same order that you are going to go in here, and they are heterogeneous and homogeneous. Okay, so those two types of mixtures are heterogeneous and homogeneous. We're going to look at both. Alright, heterogeneous, that term, prefix hetero, is meaning different. Okay, this means they are not uniform throughout. Look at some examples here. Good old alphabet soup. I love that stuff. Do you ever spell anything with it? So, you got your tomatoes, you got your pasta, right? They're not evenly mixed throughout. There's different layers. Good another way to see that is like salad and pizza. If I look at a pizza, on the bottom you have your dough. In the middle you might have your sauce. On top you have cheese and your toppings. Right? If I look throughout this whole thing, if I try to take a sample from the bottom of the pizza, I just get dough. Or from the top, maybe you just get a pepperoni. It's not evenly mixed throughout. So we call that a heterogeneous mixture. And there are two types of heterogeneous mixtures. They are called suspensions and colloids, and we'll look at the difference in both. Alright, suspensions have really large particles, right? And they will settle out. If you ever had a cup of dirty water, right, and you let it sit for a while, you'll see that the dirt goes to the bottom and the water stays on top. Something like salad dressing, like Italian salad dressing. If you just left it here, and you can kind of see it in this bottle, alright, some of the chunkier stuff goes to the bottom and the oil stays on top. That's called a suspension. Alright? And it has something called a positive Tyndall effect. Now we're going to look at this. If you wait a second, you're going to see some pictures that pop up here. But what really happens is you take a light and shine it through, okay, this was a suspension here, shine it through a container, alright? A positive Tyndall effect means a light will reflect back at you. You'll actually see a beam of light. Just wait for some pictures, you'll see it. Alright, here's some other examples. So like cereal and milk, suspension, chicken noodle soup, OJ with the pulp, stuff like that. Alright, colloids. Alright, these have intermediate particle sizes. They can't be seen. Okay, suspension you can actually see the particles. Colloids you can't. They do not settle out, but they do have a positive Tyndall effect, and it looks cloudy. If you look over here at this graduated cylinder here, you're going to see a very cloudy substance. Okay. If I tried to shine a light through this, let's say I had a red light here that I shined through this, you would actually see the red light inside of this substance. Okay? Those are colloids. Some common colloids are, well, you've seen them before, fog. Yeah, when you're driving through fog, that's a colloid. Aerosol cans and milk. Milk is a colloid. Alright, next thing we're going to look at is homogeneous mixtures. Homo means same. And this means it has a uniform mixture throughout. It's the same throughout. Okay, if you look at this beaker over here, okay, don't know what it is, but this beaker of red, if you look top, middle, and bottom, you will find the exact same substances. Alright, if I look at a cola drink, if I look at the top, the middle, the bottom, or I drink a Coke real quickly, it tastes the same all the way through, same amount of carbonation and everything. Alright, it is a homogeneous mixture. There are two types of homogeneous mixtures. Alright, we're going to look at solutions, and then actually I guess this is one type. They're all homogeneous mixtures are called solutions, but a specific type is called an alloy. Alright, solutions have the smallest particle sizes. Alright, they're very, very tiny, you can't see them. They will not settle out. And these have a negative Tyndall effect. If you take a flashlight and shine it through a solution, you won't see anything. Alright, it might hit the sides of the container, but you won't see the beam of light. And you can see the examples down here. And a type of solution? Well, alloys is a type of solution. It's actually a solid solution. If you ever had talk about alloy rims or wheels, all right, it's a combination of metals. Anybody have any gold jewelry? Unless it's, I think, 24 karat gold, it's not pure gold. Actually, if you get most gold, it's actually gold and silver or gold and palladium added to it. The reason why is gold's really soft, actually. So they actually mix some elements with it. We're going to talk more about some alloys and see some in class. Okay, so I promise you it's going to make sense. Okay, once again, these are combined physically, not chemically, so they can be separated. Why use alloys? Well, you actually are making the metal stronger, and they're usually pretty inexpensive. So alloys are a good thing. Okay, guys, so now what I want you to do is try the concept check there. You got a few questions. See if you can fill in those blanks, and we'll go over them tomorrow. All right.